In this video, I like to do two quick examples for the method of characteristics. This one here, 17.2, is quite similar to the one I just did in the previous video. We have dw by dt plus 5 dw by dx, but now it's not 0. It has a value here, e to the 3t. And the initial condition is e to the minus x squared. So in difference to the previous one, here we have not a 0 on the right-hand side. But still, we can still do the method of characteristics. So the first characteristic equation is the equation dx by dt is 5, right? That was the coefficient here in front of the d by dx term. So we solve it as 5t plus a, and then we get the anchor point, of course, is x minus 5t from this. Easy. But now what happens to the rest of the equation? Well, we again do the total derivative dw by dt. By the chain rule, we get the partial derivatives here and here. And dx by dt, this is 5. So then here we have the PDE, the original PDE, and this is e to the 3t. Right, so we get dw by dt is e to the 3t. And then we can integrate this by time. And we get w is 1/3 e to the 3t plus a constant k. Okay, fine. So now the constant k we can again get from the initial condition if we set t is equal to 0. So that's what happened here. If we set t is equal to 0, here and here, then the solution becomes 1/3 plus k. So then k is the initial condition minus 1/3. All right, and the initial condition is again at the anchor point. So let's put all this together. So then the solution along the characteristic. So the solution is e to the 3t plus k, and the k we computed is this. Okay? But now x0 is the anchor point. So we use the initial condition at the anchor point. And the initial condition is e to the minus a squared. So we get this. And then finally, we sub in what this a is. I have it at the very top in red. There. So then it continues here. This a is replaced by x minus 5t because this is how we compute the anchor point. And that's our solution. So the calculations you do are relatively simple, but it could also be confusing. So make sure you understand every step and you do it very slowly. You have the first characteristic equation here. You have the second characteristic equation here. And then the last ingredient is the anchor point, which you do there. These are maybe the three important steps. Let's do a similar one with 17.4. Now we have dz by dt plus 3 dz by dx is sine of 2 pi t. Okay, so now we are getting better and better. So the first characteristic equation is dx by dt is 3. So then x is 3t plus a is x minus 3t. Ha! We're getting quicker, we can do this more fast. Now the second characteristic equation becomes dz by dt is the total derivative here, and then from the right hand side this is sine of 2 pi t. So we need to integrate the sine, which is minus cosine. This happened here. So then z along the characteristic is minus 1 over 2 pi cosine of 2 pi t plus the constant. Okay, how do we get the constant? We get the constant from the initial condition, just subbing in 0. Cosine at 0 is 1. Okay, so then we get this. The initial condition is the cosine given up here. So then this is what we actually use right there. So it's cosine at the point at the time 0, which is of course the anchor point. The anchor point we computed is x minus 3t. So then we get the constant k written as cosine x minus 3t plus 1 over 2 pi. And then we can put everything together. So then the solution is given right here. Z is minus 1 over 2 pi cosine 2 pi t plus this k. So this was a k, where we use the anchor point x minus 3t.